This is the dataset. Okay, here I'm using explorative of data analysis before applying machine learning. Okay, so I have one dataset, Hyberman's cancer survival dataset. I downloaded this dataset from Kaggle. So let's start, guys. First of all, I imported these libraries, which are pandas, numpy, seaborn, matplotlib. I defined these pandas as pt, numpy as np, and seaborn as matplotlib. Okay. After that, I read this dataset Hyberman.csv by using pandas. Now you can see here pandas as pt, and after that, I stored this dataset into df. Okay, df variable. So next, df.head, it's print the top 5 rows of dataset with column names. Okay, but here you can see there are no column names, but we can generate the column names. Yes, we can generate the column names by using df dot columns equals to list of column names. Okay, so next, df dot head, it's print the top 5 rows of dataset with the column name. Okay, now you can see, yes, column names are generated. Okay, so age means percentage, and operation years means year of operation, 1962, 1965, 1950, and so on. Okay, auxiliary line means positive nodes of cancer. Okay, and survival status. Inside the survival status, there are two types of values, 1 and 2. 1 means the patient survived 5 years or long, and 2 means the patient died within 5 years. Okay, so next, we can check the shape of dataset. Okay, df dot shape, it's print the shape of dataset, number of rows and number of columns. There are 305 rows and 4 columns. Okay, so next, df dot info, it's print brief information about the dataset. Now you can see memory usage 9.7 kilobyte, and data types are integer type, and number of columns, number of rows for each columns, and column names. Okay, next, I want to change the survival status value, 1 for yes and 2 for no. Okay, by using map function. Okay, you can say replace the value of survival status. Okay, so next, you can see here survival status values are changed. Okay, so next, df.describe, it's describe the data set. Okay, for all columns, it's define the count, it's define the mean value, and it's define the standard deviation, and it's define the minimum whisker and maximum whisker, and 25 to 75 range of approximately percentile. Okay, so next, in this line, count the number of yes and number of no. Now you can see here inside the survival status, number of yes 224 and number of no 81. So next, in this line we can check how many patients are survivor. Okay, that means it's described for all column which have patient status only yes. It's described for all columns, means like that. Okay, it's describe the all columns which have only yes, survival status yes equals to yes. Okay, so same for no. I can see here same for no. Okay, so next, univariant analysis by using histogram. Now you can see here SNS means seaborn. I'm using a face git function. Inside this function, there are 3 variables. First one is df, means dataset, and survival status. I selected survival status for you, and height equals to 5. I set height equals to 5. Okay, and dot map, sns dot displot, I selected age for this plot. Okay, so next, plt dot show, it's print the graph for dataset, histogram graph for a certain dataset. Okay, between age and density. Okay, age in x-axis and density in y-axis. Okay, now you can see here survival status yes for blue color and no for chemical color. I think you understand this histogram graph. Okay, same for operation here and same for auxiliary length node. Okay, so next, here you can see there are two variables, counts 1 and bin edges 1 equals to np. Np means numpy dot histogram. Inside this histogram, uh, here you can see status yes. What is the status yes? Now just a wait, I'm showing you. This variable name is status yes. Okay, which have the survival status equals to yes. Okay, yes means 1. Okay, here I'm using auxiliary length nodes. Okay, of status yes. Okay, and beans equals to 10 means it's showing difference between the starting point to end point. Okay, density equals to 2. Now you can see here I applied mathematics. So mathematics counts 1 upon sum of counts 1. Okay, I store this value into pdf1 and print this pdf1, and you can see here these are the values of pdf1 list. Okay, it's create list automatically, it's created list. Okay, and also for bin edges you can see here, see this line. So next line you can see numpy np dot consum, and then np means numpy dot consum function. Here I pass the variable of pdf1 and store it into cdf1. Okay, and next you can see I plotted this bin edges for pdf1 and also plotted this bin edges for cdf1. Here just I'm using a label equals to yes. Okay, it's called cumulative distribution function. And next plt.x label nodes. Here let me show you. Here you can see I in x-axis I'm using nodes. Okay, 10 20 30 40 50. Okay, so same for counts 2. I changed this status yes to no. Okay, and for same column auxiliary length nodes. Okay, all are same. Okay, so next, now you can see this box plot. Here I'm using SNSD bond and dot box plot, and I taken x equals to survival status and y equals to age, data equals to df is our data set. So same for operation here auxiliary length node, and you can see this plot between age and survival status, and you can see this rectangular blue box and orange rectangular box. It's showing the blue rectangular box is showing survival status equals to 1 means yes, and orange for no. And you can see this below bottom line of rectangular box, it's showing 25% survival, and middle line is showing 50% is survival, are survival, and 60 line is showing so sorry, not 60 line, it's top right, the top line of the rectangle box, it's showing 75% patients are surviving. Okay, so same for no. Okay, so and operation you can see this plot, it's uh, between a operation year and survival status, and next auxiliary length node and survival status. Okay, so You can see this violin plot. It's same as box plot. Same as box plot. Just I written here violin instead of a box. Okay. You can see this box plot and violin plot. Okay. So first plot is between age and survival status. Now you can see this. Yes. You let me show you. Just remove this part, right part. Remove this right part, and you can see this line. You can see this line. It's histogram line. Okay. So and the middle colors is showing density. Left side you can show this. You can see this color. It's showing density. Okay, but you can see this both part are left and right part are equals. Okay, so you can take any one part. Either you can take left part or right part. Okay, same for all. Okay, next is pair plot. But you can see inside this pair plot there are three charts, one, two, and three. And I'm taking upside of chart. Means you can see this three charts. It's same. Okay, uh, above diagonal and below diagonal. Both are same. Okay, equal. But here I'm taking above side. Now you can see this first chart. It's not showing clearly. All points are very close. Okay, blue points and orange points are close. Okay, so let's see next. Here blue points are close, but some uh, orange points also it's a cover, and maybe it's hidden with blue points. Okay, so this chart is also not useful. And see this last chart, it's also not useful. But you can see this points, blue points and orange points, it's overlap. Okay, and hide some points, either blue points or either orange points. So this chart is not, these charts are not useful for me. Okay. Okay. So next, multivariant analysis. Now I'm using joint plot between operation year and age. Okay, so now you can see this chart, uh, see chart, and you can see this area. It's very high density area, and also you go from outside from this middle point, middle area, and its density density is decreasing level. Okay, so now last area, you can see this last area, it's very low density area. Okay, and but in middle area, it's very high density. Okay, so you can see high density means 45 to 55 ages patient. Okay, and you can take from here operation year between 1959, or you can say 58 or 50. You can take 58 or 59, 1959 to 1960, 1963 or 64. Nine, you can take 1964. Okay, means you can say between 1959 to 1963, uh, 45 to 60, 55 age patients are have high density. Okay,